This video is all about collision theory. Let's consider the reaction between H2 and I2. We'll color the H2 molecules red and the I2 purple. Let's watch them as they move. Was there a reaction? No, there was no reaction. Why not? The basic idea or the basic premise of the collision theory is that in order to react, molecules must collide. And as you can see, they didn't collide this time. So does that mean they'll react every time they do collide? Okay, let's watch these molecules as they approach each other this time. This time they did collide, but they didn't react. They bounced off each other unchanged. So why didn't they react? Well, it's because they didn't have enough kinetic energy, or energy of motion. In order to collide hard enough to cause a chemical reaction, that, by the way, is called a successful collision. Particles must collide with a certain amount of kinetic energy. The minimum kinetic energy particles must collide with in order to have a successful collision, that is, result in a reaction, is called the activation energy, or EA. Having anything less than this energy, they will not have a successful collision, and there won't be a reaction. Having this energy or greater will give them a successful collision. Let's consider this collision, this time with a little more kinetic energy. When the particles collide with enough energy, they form an unstable combination of atoms. This is called the activated complex, and in this case it has the formula H2I2. If they collide with enough energy, the bonds in the H2 and the I2 will break. And then what happens is new bonds will start forming between the H's and the I's. Now what happens is the new HI molecules, called the products, start moving away from one another. So the chemical reaction is now complete. The two new products, two molecules of HI, have now been formed and are stable. We can summarize this whole process now. The reactants, H2 and I2, collide to form the activated complex, H2I2, an unstable arrangement. The activated complex then breaks up to form the products, two molecules of HI. Okay, watch this collision between H2 and I2 molecules. Was this collision effective? No. Why not? Well, let's take a closer look. Notice how the red H2 molecules are oriented in space, like that. When the molecules collide, the red H2 molecules are not oriented in the correct way to form the activated complex. They're not lined up the right way. Recall that in order to form the activated complex, they should have been oriented this way, so each H can hit an I. In this case, they form the activated complex, and this is called a successful collision. But that's not what happens in this collision. We can say that these molecules do not have the proper orientation for a successful collision. We can also say that they don't have the proper collision geometry. One more term we can use for this is alignment. We can say the molecules don't have the proper alignment for a successful collision. So we can now summarize a collision theory. The three requirements for a successful collision. The first one is the molecules must actually collide. They can't miss. The second one is they must collide with sufficient kinetic energy, greater than or equal to the activation energy. And the third requirement, they must collide with the proper orientation, alignment, or collision geometry. In that case, there's no reaction, because they didn't have the proper collision geometry. In this one there is a reaction because they did.